So for number one, part A is asking you what's the probability that C is greater than 1.4. And remember, you have two choices. You can use the table or you can use the calculator, and I'll show you both ways. So I told you you should always do a diagram or a picture of what you're trying to find. So this is what we want, which is what I call the green color. And then you look to the table for 1.4 is 91, 92, right? So that's either that or what I call the area to the left, but I think it's easier to follow the colors. So therefore, you're not. So to find this using the table, since you want the green area, remember the green area is 1 minus the yellow, or in this case it will be 1 minus 0.9192, which according to what I have here is 0.080. Is that okay?
Yeah.
Now, if you use a calculator, remember to access the function, you need to go to second and then variables, and then make sure you pick number 2, which is normal CDF. What is the lower bound in this case is 1.4, right?
Yeah.
And the upper bound will be 1,000, which is infinity, and it will give you exactly the same thing, 0.0808. Is that okay?
Yeah.
All right, so let's move to number 2. I mean, not number 2, part B. Let's do the diagram first. You have 0, -1. I mean, sorry, this should be +1. This is -1. So you want these two blue areas. So this is the first one, and this will be the second one. So first, let's look to the table. If you look to the table will give you a 0.8413, right?
Yes, on both sides.
Yeah, on both sides actually, because it's symmetrical in this case. So therefore, this part only, this should be 0.84 minus 0.5, which will give you what? 0.3413, right? And then this one should also be 0.3413. So therefore, the solution using the table is 0.3413 times 2, or just add it twice, which is 0.6826. Okay. Now let me just make a particular note of this example. So if you run to two places, clearly this is 0.68. Okay. You should always keep 4 places for this, but you'll see why I'm making this note. 0.68 is the same thing as what? 68%. Okay? And you remember in chapter 3, when we talk about the empirical rule, remember you move one standard deviation to each side. I just give you the values and you just have to trust it. And I told you it was 68%. So those values come from this table. Remember, you move 2 standard deviations, it was 95%. So that will be between -2 and 2. So those values, the empirical rule is the same thing as the normal distribution, just for the record. All right, so now part C. First, okay, draw the picture. -1.49 is here. Actually, before I keep going to that one, what will be the calculator commands for this one? So this will be normal CDF. The lower bound is what? -1. And the upper one is 1. And it should give you the same answer. Is that okay? Just in case you want to use the calculator. Right, now in this case, less than -1.49 is to the left. So they technically asking you for the green area. So if you look to the table, what's the value that the table will give you?
0.9319.
9319. Very good. So remember, to find the green area will be 1 minus 0.9319, which according to what I have here is 0.0681, right?
Yep.
Now, if you use the calculator, what is the lower bound?
Negative 1,000.
Yes, and what about the upper bound is negative 1.49. And again, it should give you exactly the same answer. Is that okay? All right, so far so good. Any questions? Okay.
So far so good, Professor.
Good. Now let's look to these values, which I told you this notation is going to be used a lot in chapter 7, 8, 9, and 10. So again, what does this actually means? Remember, this is the green area or the area to the right. So what this means is that there is a value which we call it 0.03, where this area is 0.03. That's all it means, which means the area to the left, which is the one that is on the table, is 0.93. Okay? Sorry, 97.97. And we can just put 0.9700. Actually, let me write like this, 0.97. And this is the one you had to look for on the table. Is that okay? So if we look to the table, then the closest thing to 0.97 is 97 is between these two, right? So I mean the closest one for sure is this one, which is 1.88. Is that okay? So therefore the answer is, if you use the table, is 1.88. Now you use the calculator, this will be inverse norm, and the area to the left is, or the yellow area is 0.97, and it should give you also 1.88. Is that okay? Any questions on this? All right. Part B is identical, except that the area being 0.03 is now 0.07. So therefore this is 1.88. So this area then is now 0.07, which means this one will be 0.93, right?
Yes.
Yeah, I knew there was a 0.93 somewhere. All right, so if we do the same trick, what will be the answer? Anybody?
1.48.
1.48. Thus, if you use the table, for the calculator, it will be inverse norm 0.93, and it will give you exactly this. Right, so far so good, right? For number 1 and number 2.
Yeah.
All right. All right, so let's try number 3. So here is the key that you had to use the normal distribution, because it tells you it's normally distributed. The mean is what, 260, and the standard deviation is 25. All right, so far so good. So here x is going to be the range, pretty much, okay, or how many miles you travel. So the first question is asking you, what's the probability that a randomly selected Tesla can travel more than 310 miles? So technically they're asking you what's the probability that x is greater than 310. So remember, you had to do the standardization on the side. So this will be 310 minus what? 260 divided by 25. And this is how much? 2.0, right? So remember, we're using the formula x minus mu over sigma to find the z-score. Right, so then this is pretty much the same thing as the probability that c is greater than 2, right? So far so good. And then we draw the picture. Well, greater than 2 is the green area. It's this part. And if you look to the table will give you which value? 0.9772, I think, right? Is that right?
0.9772, yes.
Yes, okay. Eventually you memorize these values by doing so many times, we'll see. So it's 0.9772. So how do we find what we want? So remember, this is what you want, the green part. So it will be 1 minus this, which is equals to what? 0.00. Yeah. That's it. Now, what about you use the calculator? Which one is the lower bound and which one is the upper bound?
Lower would be 2,
Yeah.
upper would be 1,000.
Yeah, that's it. Okay. Is that okay? So far so good?
Yeah.
Okay, now part B is asking you what's the probability that x is less than 300, right?
Yeah.
So do the same trick. Z will be now 300 minus 260 divided by 25, and this is equals to 1.6.
1.6.
Okay, so then this is the same thing as the probability that Z is less than 1.6, and draw the picture. So 1.6 is here. Less, remember, is asking you to the left. So this is what you want this time. What is the value from the table for 1.6? Is 0.9452. Is that right?
Yes. Yes. 9452, yes.
So then this is the answer. So I told you for something like this, the table is faster. Or the calculator will be normal CDF. Which one is the lower bound this time?
Negative 1,000.
And the upper bound is what? 1.6, right? And this should give you exactly 0.9452. Right? So far so good?
Yeah.
All right. Told you this was easy. Okay. So now this one is asking what's the probability that x is between what? 235 and 310, right? So we already did the value for 310. The value for 310 was 2. So we just need to figure out the value for 235. So Z will be 235 minus 260 divided by 25. And how much is this? It's -1, no?
Yes, that's what I.
Yeah, so this is -1. All right, so then you're trying to find the area between -1 and 2. So remember, if you use the table, you had to do 2 blue areas, one for 0 to 2, and the other one from -1 to 0. And yes.
I'm sorry, so you do the formula for each number?
Yes, whenever it's 2, because you have technically 2 blue areas, so then you have to use the, oh yeah, here, if you have more than one number here, you need to do the z-score for this one and for this one. Okay?
Got it.
Okay. All right, so now the table for 2, it was what, 0.9772. So therefore, this part right here will be 0.4772. And then the value for 1 was how much? 0.80. 8413, which means this is equals to 0.3413, right? So therefore this will be 0.3413 plus 0.4772, which is how much?
0.8186.
0.8186, all right? Or what will be the calculator? Which for this one, the calculator will be much faster, but normal CDF, the lower bound is -1 and the upper bound is 2. Is that okay? So far, so good? All right. Now, part D and part E now are from section 6.3. So now part D says, now suppose that you pick a random sample of 9, so n is 9. Now, can we use the center limit theorem or not? So let's answer actually part E first. Does the center limit theorem applies in part D? Yes, no, and why? Okay, so the answer is yes. Why? Because the original distribution is normal, okay? Because that's what I told you at the beginning. So since the original distribution is normal, then you don't need to have 30 or more. That's why it works, okay? Remember, this was the example with the Pepsi. If you have 2 Pepsis or 3, they're Pepsis. But if they're not Pepsis, you need to have at least 90 or more. I mean, 30 or more. Right, so therefore, this is the formula we're going to use now because they give you a sample. So it will be n, and this is x bar minus mu over sigma. So what will be the c-score here? So this will be the square root of 9 times what, 250 minus 260 divided by 25. Because essentially what the question is asking you now is what's the probability that x bar, remember that's what sample mean is, x bar is greater than 250. So how much is this, anybody? All right, so this 250 minus 260, that's minus 10, right? So minus 10 times 3, that's minus 30. So it's minus 30 divided by 25, or just 30 divided by 25. So what is that?
30 divided by 25?
Yeah. Negative, what is it?
1.2.
1.2. It's negative because 250 minus 260 is negative 10, right? That's where the negative comes from.
Okay.
All right, so then draw the picture again. Always put 0 for reference. Remember that negative 1.2 is here. So greater is this. So they are essentially asking you for the table value, okay? Or the yellow area. So 1.2, what's the answer for 1.2 anybody?
0.8849.
What is it, Javier? Point what?
0.8849.
And this one, we don't have to modify anything. This is 0.8849. That's it. What about the calculator? This will be obviously normal CDF, okay? But what is the lower bound and what is the upper bound?
Negative 1,000, and then upper would be negative 1.2.
No, close. So remember, you're going now from here to here.
Oh, negative 1.2 and positive 1,000.
Yes. Okay. So now you can see for some problems, the table will be faster than the calculator, and for other, the calculator will be much faster. So that's why it's good to know how to use both of them, but you can just use one. It's fine. All right. Any other questions on this? I told you it was pretty simple.